Memory complexity analysis. Memory, or space complexity, is the amount of memory needed in the execution of an algorithm. This is usually determined by examining the data structures used. Memory complexity of some algorithms. What are the memory complexities of linear and binary search? So, to find out, we'll simply review the code. If you have reviewed the code, the data structure used for both is an array of size n and some constant variables. Therefore, both of them have a memory complexity of n, or theta of n. Let's look at this dynamic programming code for getting the factorial of n. What is its memory complexity? If we look at the data structures used, it's just a few variables and nothing else, as you can see here. Therefore, you could say that its memory complexity is constant. It'll never change. It will always be the same, regardless of what n is or what I is. So, it's theta of 1. Now how about this recursive implementation of factorial? Seemingly, it only uses one variable. But if you remember, this will have multiple recursive calls before it finishes. And how do we implement recursion or function calls in general? You would have learned this in Computer Science 1 to 4, programming languages. So if you remember, recursion or function calls are implemented using a stack. So a stack is either implemented using an array or maybe a list. Therefore, its recursive implementation has a memory complexity of theta of n. So again, the dynamic programming version is constant space, it'll never change, theta of 1, and the recursive implementation has a memory complexity of theta of n. The same actually applies for the Fibonacci problem. So the Fibonacci problem, its dynamic programming algorithm version is constant time, constant space rather, and then the recursive one is also theta of n.